This video is about nickel plating using nickel sulfate and nickel chloride to nickel plate. There's quite a bit of information on this board. I'll try to go through this as quickly as I can. Nickel plating as a finishing process was first done in 1837 by British physician Dr. Golding Bird. It was more refined by German physician Dr. Rudolf Bürtger in 1843, and this was all following the first ever electroplating, which was done using silver by Italian chemist Luigi Brugnatelli in 1805. Today, most nickel plating is done with what's called the Watts bath, and that was designed by Oliver P. Watts in 1916, and he did it at the University of Wisconsin. And this Watts bath included nickel sulfate, nickel chloride, and boric acid. Nickel plating can be done with nickel nitrate and boric acid, and nickel nitrate, which I made in a previous video, was actually what I was going to start with when I looked into nickel plating. But after some research, etc., this Watts bath came up, and I researched that some more, and it looked like the right way to go. So even though this is what I started with, the nickel nitrate, and it was the main reason I made it, I changed directions, and nickel sulfate and nickel chloride are going to be what I use. Whatever you use to nickel plate, boric acid is needed to maintain the correct pH. It works very well in this situation because it's a long-term pH corrector or a buffer, and for that reason it works good with nickel plating because you need to let this run for some time. Boric acid is a weak Lewis acid. It is electron deficient, and around the cathode of our Watts bath that we're going to be using here, hydroxy ions tend to collect, and the boric acid is what will be used to bring the pH back down so it doesn't become too basic. And speaking of that, I just want to show you quickly how boric acid works because it is not typical. So you have a boron ion in the middle surrounded by 3 hydroxy groups, and you could write boric acid as BOH3, which makes it look like a base. It's written as H3BO3, but if you looked at it like this, you think, hey, it's a base. It's not. And the reason it's not is because this boron atom is electron deficient, as I mentioned, and it'll attract the oxygen and one of its hydrogens towards its center, becoming a symmetrical unit here with 1 boron atom and 4 hydroxyl groups around it. And that's called the tetrahydroxyboric ion. When it does that, it releases one of the hydrogens into the solution, and that hydrogen is now free to protonate. So that's how boric acid actually works as an acid. It's pretty weak, and you do need water in the solution for it to actually work, but most things do have water in it when you're talking about solutions. So, all right, that's how boric acid works and why we're using it. Since we're talking about pH, in this experiment, we want the pH to be between about 4 and 4.5. I really try to keep it between 4 and 4.3. If the pH goes above 4.5, we're going to use a 5 to 10% sulfuric acid solution and do it very slowly because the pH can change quite abruptly when you're using even a weak sulfuric acid solution like this, to keep it in that 4 to 4.3 range because it's important. That pH will make or break the nickel plating solution. Coming back to here, I'm talking about the nickel nitrate here. Nickel nitrate is not nearly as effective as using the Watts bath, which is the nickel chloride, nickel sulfate, which is the industry standard. And the reason for that, you got to come down here, and that is nickel sulfate is a primary source of nickel ions, and nickel chloride improves the conductivity. So the mix of these two provides a lot of nickel ions. Obviously this does it too, but the chlorine also improves the conductivity, which is important, and it also helps the anode lose nickel. The anode is going to be made of nickel metal, and it is a constant source of nickel ions that can replenish the solution, and it's the nickel chloride that really helps this process work. So that's why this Watts bath is so much better than the nickel nitrate. As I mentioned, boric acid is used regardless of what nickel source you're going to use to nickel plate. But the other nice thing about it is because of how it acts, it actually helps put down a smoother surface of nickel on whatever you're nickel plating. Without it, you'll get a rougher surface. With it, you get a better surface, and you get an even better surface if you use polishers. And there's a whole list of them. There's about 8 to 10 things you can use as polishers. I'm going to use urea and saccharin because I have those two. Sodium lauryl sulfate, which you'll find in shampoos and soaps, also works. And like I said, there's others. The reason these work is because they slightly inhibit the nickel plating process just a little bit, and allows the nickel to thereby be plated smoother without it starting to clump up on the surface that you're nickel plating. Moving on to the materials. Nickel sulfate, 113 grams. Nickel chloride, 21.19 grams. Boric acid, 15 grams. Saccharin, 1 gram. Urea, a half a gram. You need a power source. I'm going to use a 5% hydrochloric acid solution to wash things. I'll probably brush whatever I'm going to do mechanically first with a wire brush, and then soak it in here just for a minute or two to clean it really well. And then again, a 5 to 10% solution of the sulfuric acid in order to change the pH if we need to. Now, if the pH drops too low and it's more acidic than we expect, sodium hydroxide is really the best thing to use that when it's in a solution. So we'll have to wait and see how it goes to see how the pH turns out. Going over a couple of reactions, they're really straightforward. At the anode, you've got nickel metal. It's a nickel rod I'll be using, which produces nickel ions. Again, the nickel chloride we're using helps this happen, but produces nickel ions plus 2 electrons. At the cathode, the nickel ion plus 2 electrons yields nickel metal on top of whatever we're nickel plating. So the electrons flow from the anode into the power supply and then back to the cathode and then through the solution, and on it goes. In our methods here, we're going to take the nickel sulfate, nickel chloride, the boric acid, the saccharin, and the urea and dissolve it all into around 500 milliliters of water here. I'm going to get this temperature up to about 70 to 80 degrees Celsius so they all dissolve really well. Now that's too warm to do the nickel plating. So what we're going to do next is drop it to around 50 degrees Celsius, which is a really good temperature to do the nickel plating with the Watts bath. And then we'll use sodium hydroxide, as I mentioned, or the weak sulfuric acid solution to get the pH right where we want. And again, I wrote 4 to 4.3 right here. Then we're going to take whatever we're going to nickel plate, which will be the negative cathode, hook it up to the power supply. Here's a nickel rod right here, power supply. I'll mix it just to keep the solutions mixing really well. And we're going to run it at 2 to 3 volts. 2 volts for all metals except for copper, which should be run at 3 volts. Just to encapsulate everything real quick and go over what I said with the diagram. So the power supply is providing the electrons are going down the cathode, which is a negative, into what is I'm going to be using as a piece of copper right here. They then cross through the solution. They're picked up by the anode, the positive, which is going to be a nickel metal rod right here, and then they go back into the power supply, come back out, and so on and so forth. So that's the circuit of the electrons. Over here, where I'm going to have the copper and the negative cathode, you're going to see positive nickel ions collect on this area here, which will be mixed with the electrons that are coming through here, according to this reaction right here, and plating that copper. And then on this side, we've got the nickel rod, which is going to be losing nickel. That's these nickel plus 2 ions crossing like this way, but it'll be collecting around it the chlorine and the sulfate and the chlorine ions from nickel chlorine and nickel sulfate. So those ions around here won't create much of a difference. They just don't change the pH that much. But around here, we're going to be collecting our hydroxy ions over time, which will push the pH up, make it more basic, and that's why we're using our boric acid mostly around the cathode right here to keep the pH lower. Okay, that's a wrap. There are more details, but this is already enough to go through, and I'll say more as we do the experiment, but let's go ahead and use our nickel sulfate and chlorine, which we've already made, to nickel plate. 113 grams of nickel sulfate made in a previous video, pre-weighed. 21.19 grams of nickel chloride, also made in a previous video, pre-weighed. 15 grams of boric acid, pre-weighed. 1 gram of saccharin taken from a sweet and low package to be used as a polisher, pre-weighed. A half a gram of urea, also to be used as a polisher, pre-weighed. And here are the 2 electrodes we'll be using. For the anode, I'll be using a nickel rod here, solid nickel rod, as I mentioned earlier. All I did was solder a wire to it and then protect it with some shrink wrapping right there. And I did brush it good mechanically to make sure that it was clean as possible. And then for the cathode, which is what's going to get nickel plated, I chose this Winchester 300 round. Obviously, it's been used, but I think it'll be cool because it's copper, and to make it shiny nickel will look pretty good. So that's the cathode right there. Both of them have been mechanically cleaned, meaning I used a brush on them, but just before I use them and put them in the Watts bath, I'll also dip them in a 5% hydrochloric acid solution just to make absolutely sure they're clean before we run the electrolysis. In addition, I hope to nickel plate a number of different things. Because we're using the nickel rod, we'll have a continual replenishment of nickel ions. So here was a very dirty 2016 penny. I dipped it in some of the peroxyacetic acid that I made last time for about 30 seconds, and it cleaned it like super clean. But what I plan on doing is nickel plating it. It'll look like a 1943 World War II steel penny. That's not the idea there, but it'll, I think, look pretty cool, even though it's a 2016 penny, and we'll do other stuff. All set to go here. I have around 300 milliliters of distilled water in this container. It holds 500, but I'm doing that because we're going to be adding so many solids that if it were filled to 500 milliliters and then we had the solids, it's probably going to spill over. So I'm going to heat this up to around 80 degrees Celsius and then dissolve the solids in it as much as possible. Hopefully, we might have to add a little water, but get them all dissolved and then fill it up to the 500 milliliter mark. but of course we'll drop it to 50 degrees Celsius when we're actually running the nickel plating. The power source is not set up at all. It's obviously just sitting there right now, which is fine. So I'm going to start the magnetic stir in the heat. I'll be back when this is ready around 80 degrees Celsius. I understand you can't see this really well, but it's at 76 degrees Celsius, and I'm going to call that close enough. And we're going to start to add the nickel sulfate. All of the nickel sulfate dissolved nicely. Next, we're going to add the nickel chloride. The nickel chloride dissolved nicely. Now we're going to add the boric acid to help regulate the pH. Took a bit for that boric acid to dissolve, but it finally did. And it's time to add the brighteners. The first one is the saccharin, which is exactly 1 gram. I'm going to add that now. And adding the urea. We're about 10 milliliters from the 500 milliliter mark, so I'm just going to use this distilled water sprayer here and make it 500. Okay, I need to bring the temperature down now to 50 degrees Celsius from around 76. And then at that point, we can put the electrodes in and actually start our nickel plating. This has been cooling down now, and I've let it cool down past the 50 degrees Celsius mark because as it was cooling, I started to check the pH and was a little surprised to find how low it was. So right now, it's around 30 degrees Celsius or so, but I'll show you the pH here in just a sec. So here's the pH. I think this will show up okay here. 1.81, 1.80. That's really low. Far, far too low to do nickel plating with. So a couple of things happened. Number one, I miscalculated the amount of boric acid needed, which is possible, and just added far too much. Boric acid is a pretty weak acid, and I don't think that's why it's at a 1.8. I think the other reason, which is more likely, is I made both the nickel chloride and nickel sulfate using, of course, hydrochloric acid and sulfuric acid, and although I washed them well and dried them completely, I think there was still some acid left in them, and the acids in those nickel substances, and then with the addition of the boric acid, just dropped it extremely low here. It's not extremely, but it's definitely too low. So the best way to fix this is with a weaker solution of sodium hydroxide. So here's my 1 molar solution of sodium hydroxide. I made 100 milliliters of it by dissolving 4 grams of sodium hydroxide in 100 milliliters of water. And I'm going to be adding this maybe a half a milliliter to 1 milliliter at a time, and then checking the pH to make sure I don't overshoot this. So I'll start doing that, but most of this I'm going to do off camera. I'll just show you the end result because it's going to be tedious. So here goes. Ten drops, half a milliliter. So I'm going to let that mix up good. I added 10 milliliters of the 1 molar solution of sodium hydroxide, and of course it buffered the pH. I've been checking it all along, and this was pretty close last time I checked it. So let's see. 3.97, 3.98, 7. Definitely close enough. We'll call it a 4. It's going to go up gently anyways as we do the nickel plating, which we can finally do right now. I've got both of these electrodes in this plastic bag since I wire brushed them, so they've been protected, but I'm going to follow through with the 5% hydrochloric acid wash just to be sure. So I'm going to take this. It doesn't have to be in there too long, maybe a minute or so, but I'm going to put this down in here like so and just let it sit there. All right, it's been a minute, and actually it looks a little shinier, believe it or not. I'm going to dip it in this distilled water now. Of course, I'm not filling it with either one of these. All right, our copper is all set to go. I'm going to hook the electrode back to it, and then we'll move on to the nickel rod there. Nickel rod's been in there for about a minute or so again, into the distilled water, just to get the hydrochloric acid off briefly. And that one's all set with the wire. It's kind of nice. Just making sure we're maintaining our temperature, and it's at 54 degrees Celsius, so we're good. I'll take this out, and we'll put our nickel anode in. All right, and in goes our copper cathode. I'm not going to dump it all the way in. I don't want it to fill. Plus, I'm trying to preserve the clip here from interfering with anything. So, yep, that looks like a good hookup right there. And I'm going to hook up the cathode negative right here, like so. Let that kind of fall to the wayside there. You'll notice I have it at around 3 volts, which is necessary for the copper in particular. Some metals, as I mentioned, 2.5 volts, but copper requires 3 volts. And last and far from least, we're hooking up the anode. And finally, we're actually nickel plating. You've got good numbers here, 3 volts, about half an amp, which is right for that size of the copper cathode there. And see you soon. It's only been running a couple minutes, but just a quick review. I'm only going to probably plate this with somewhere between 2, 3, maybe 4 microns at the most. I'm not going to be able to tell that actually. I'm going by the timing of the whole bath running here. But I'm just going to start low and slow. It seems like the right place to start. It's been running about 30 minutes, and you can see where the solution occasionally kind of laps up the side of the copper cylinder there, how it's turning silvery, which of course is the nickel plating, and that's a great sign. I said in the beginning I'm going to let this run an hour, and I wanted around 4 microns, but I just did some research and some math, and I overshot this by a bit. It's been running about an hour. It probably has 20 microns, whippy, of nickel on it. It's still a very thin layer, of course, but I'm going to stop this soon here, and we'll take a peek at it in the next couple minutes. You'll notice I put the nickel rod on its side there, just because more of the nickel could fit in the solution. First thing I'm going to do is just turn the power off here, and then I'll stop the magnetic stir and the heat. It's not going to drop that much, but let's turn everything off. Let's take a peek at our, look at that. Pretty sweet. Nice nickel shiny coating on it. I didn't want to dunk the whole thing in it. That would have been neat, but yeah, turned out really well. After each run, I'm going to check the pH. We, if anything, expect it to go up. I have not checked this yet. Let's see where it's at. Sure enough, 4.75. I'm going to add a touch of sulfuric acid to bring it down at this point. I'm going to turn back the magnetic stirrer on in the heat. I have a 10% solution here of sulfuric acid. I'm going to add a very small amount. It's around 0.4 milliliters. That's all. All right, checking the pH one more time after the addition of the 10% sulfuric acid. And you can see just that little bit dropped it down to 4.25, which is great. We're going to leave it right there for the next run. So I said I'll try this penny, so let's give it a try. Unfortunately, I can't submerge it again. I don't want the metal in the clip to be part of the chemistry that's happening in the solution. So I'll just put this down as far as I can, and we'll see what it looks like. All right, there we go. I was able to get it a little better off camera, but let's turn the power on here. And obviously the amperage is much lower because the surface area of that penny is much lower. So I'm only going to let this run maybe a half hour. See you when it's done. All right, a half hour is up. Do the same thing. We're going to turn the power off. Turn off the magnetic stir. And let's take this out. And something dawned on me, and that is if I just move the penny around a bit, I can continue to nickel plate the whole thing. Look at that. That's really something. So I'm just going to twist it a little bit. That's what I was talking about. Okay, turn the magnetic stir back on in the heat, and I can nickel plate the area that did not get it the first time. It's been around 25 minutes. I'm going to call it quits. I'm sure that's long enough. And look at that. A nice silver penny from 1916. I don't know if you can catch it in the light. It's actually pretty shiny. The surfaces are coming out really good. You can see right there where I actually scratched the penny a little deeper than the copper was, but yeah, pretty amazing. It's almost a mirror finish. Next in line is going to be this old screwdriver. It's probably 20 years old. I did brush this with a metal brush, dipped it in the 5% hydrochloric acid, etc. I also did that with the penny, by the way. So let's put this in there, see if we can't shine up the bottom a little bit. Turn the power on and the magnetic stir again. I just remembered this is not copper. We can bring it back down to around 2 volts or so. That's good right there. It's running 35 minutes at this point. Turn the power off and let's take a look. Check it out. Nice. Very, very nice. Yeah. Well, it probably, in fact, it won't change the function of the screwdriver at all, but it does look nicer. This next piece is kind of interesting. This is a tool that I found with my son. About 10 years ago, we used a metal detector and found a pile of tools in my backyard about a foot down. And this is one of the pieces. They were all rusted really bad. So I brushed this up, also cleaned it with the hydrochloric acid, etc. So I'm gonna hook this up and let's see what it does to it. I left the top undone the way it was kind of found, just so we can compare what this looks like when it's done. All right, turn on the magnetic stir and the heat and the power. Again, it's not copper, so we'll leave it at around 2 volts. All right, it's been a half hour. Let's see what this turned out like. I'm not looking for a mirror surface on this for sure, but just something out of interest. Just like the other ones, You can see here where I brushed it, but didn't plate it. This is, of course, how it was originally. And you can see this. It's not mirrored, but boy, these are turning out really nice and shiny. It's something else. Okay, cool. Before we do the next item, I'm just going to check the pH again. It's gone up again. Expected, 4.79. So, yep, I'm going to add another probably 0.4 milliliters of the 10% sulfuric acid solution. I'm not going to go over all that again. You know what happens. The next thing I'm going to do is actually nickel plate half of this lab spoon I have. It's very cheap, but it's been beat up and probably put in pretty much every chemical that you've ever seen me do on this channel. So let's nickel plate at least this part and make it look better. It's been another half hour here. Let's take this thing out and see how it turned out. Well, pretty much like everything else, nice and shiny, covered in nickel. This has really been fun. It's a little rough on a couple places here. I didn't brush this as well as I did some of the other things, and I think that's why. But hey, looks better than the other side, that's for sure. Next thing, we got a nickel plate of nickel. But look at this. Well, it's hard to see. The light is actually bleaching it out a little bit, but trust me, it's a very, very shiny nickel. For the next thing, I'm going to nickel plate my cat. Oh, sorry, Tiger. The one thing we haven't done is look at the nickel rod that has been the anode this whole time. I suspect it hasn't changed much. Over time, it would definitely be getting smaller if we did enough nickel plating, but it looks exactly the same as it did before. Here's the items that I nickel plated. The screwdriver looks brand new on the bottom there. This is kind of neat. I can now use a very shiny spoon. This old wrench turned out pretty neat. It's got the pitting from, because it was older, but it's still shined up shiny silver from the nickel. And this was the first piece we did, which turned out great. And we've got this extremely shiny nickel. I mean, it's like a mirror practically. And 2016 penny that should not exist. So yeah, really interesting. This is a really functional chemistry experiment because of what you can do with it. But thanks for watching. Last thing I want to show you is the Watts bath material. I filtered it and cleaned it up nicely. Gotten a little cloudy with particles, etc. But this can be reused now over and over again. As long as I use the nickel anode to continue to supply the nickel ions, this can last for a very, very long time. Now I'm done.